Yeah,
Oh,
but
that's a long time.
it's a long time. I don't think we're going to be here to see it, but you know, it's not a long time when you think that the universe is 13 billion years old. So
13 billion?
yeah,
Wow, that's old.
well, that's 13 and 9 zeros. So that's a long
13
time.
nine zeros.
Yeah, yeah, yeah. So so
Wow.
here's now I want to talk about an actual black hole, a real black hole, okay? Because I said I would show you one. And
Uh,
this picture on the right is a picture, it's a cartoon, it's a painting of the galaxy, our galaxy. We live in a galaxy. The sun
the,
is one star
the
in our
Milky Way
galaxy.
galaxy.
That's exactly what it's called, Milky Way galaxy. And now you can't see this view of the galaxy, right? If you wanted to see this view of the galaxy, you'd have to like jump out of the galaxy real far and turn around and take a picture. No one's ever done that, okay? So this is a cartoon of what we think our galaxy looks like. Look over here. Look in the center near the bottom. See that
That's our
circle?
sun.
It says sun. So that's where we're at. And then see the spiral arms? That's pretty cool. The spiral arms zipping around the center. And then right in the center, right where my cursor is, that's the galactic center. That's the center of our galaxy. Now it turns out
Of our galaxy.
there's a black hole in the center of the galaxy,
Well,
but it's a special black hole. So far, when I've been telling you about black holes, I've been telling you that one star collapses and forms a black hole.
yeah.
In the
Only
galactic
massive.
center, in the galactic center, there's a black hole that has 4 million solar masses, 4 million times the mass of the sun. So it's as if 4 million stars collapsed and then they all collapse together.
4 million.
So that's called a supermassive black hole.
Massive black hole.
Supermassive, super duper massive, right?
4 million times the mass of our sun.
Yeah,
That just blew my carburetor off.
I know. Mine too. That's what I said when I first learned about it. By the way, I'm one of the ones who measured the mass in the late 1990s. I
Well,
made a
how did
measurement
you
of
do
it.
that?
Well, I'm going to explain. I'm glad you asked that question because that's exactly what I was going to tell you. So now let's move on. Here's a movie I had made. I hired someone to make this movie for me. It starts out as if you're in your backyard. See the trees?
Mm-hmm.
It's like you're sitting in your backyard. Now I'm going to play this movie, and what I told the guy making the movie, I said, "Hey, I want you to make a movie like I'm sitting in my backyard. I'm going to jump out of my seat into the sky towards the galactic center, and I want to travel to the supermassive black hole. You ready?
Ooh,
Let's do it. Watch.
here we go.
Okay, here I'm going to jump out of my lounge chair. Whoop, there I go. Going towards the center of the galaxy in Sagittarius. Oh, there we go. Now this is an animation. These are the stars in the center of the galaxy, and watch. Tell me if you can see the black hole.
But where? That's it.
That's
That's
it.
it right there.
That's it.
Upton, do you see it too?
Yeah.
Kenny and Bobby, do you get to see how we traveled all the way there?
Yeah, that's pretty cool.
The
It was so
difficult.
cool, Kenny. It felt like you're really there.
I can't live there with mommy.
No, don't look for his mom. She doesn't go to the galaxy today.
Don't get sucked in, right?
Now,
Well,
Black holes are very hard to see.
Yeah, it's hard to see. The only way you can see it is you can't see stars that are behind it, and so you can tell it's there because it's really black in that spot.
Because,
yeah.
You notice?
because black, because
Yeah,
space is
it-
black, and the black hole is also black as well.
Yeah,
So
take a
that's
look.
why it's difficult to see.
I just stopped the movie, okay? And notice that where the black hole is, you don't see any stars behind it. But look over
No.
here. You can see stars everywhere, but you can't see the stars there. So that's why we know it's a black hole. So I'm
Mamma
going to
mia.
show you how we figured out that there's a black hole in the center of the galaxy. And this is another animation, but these dots here, each of these dots is a star like the sun. They're pretty big. And see these blue circles? These blue things just show you
That's a ring.
the stars that are orbiting a central point. Now I'm going to press play. This is a movie, okay?
This is from 2000.
Yeah, see that 2000? That means this is where the stars were in the year 2000.
They did have like
Now I'm going to play the movie and you're going to see the date change. And when you see the date change,
Is it going to increase every year?
yeah, let's try it. Watch, I'm going to press play. Here we go. See the stars moving? Look
Yeah.
real close.
Yeah,
Look at the
that's
date.
pretty cool.
Oh.
Ooh, look, there's
Sing both.
a big ball of gas coming into the black hole. Look,
Ooh,
look, it got ripped
the
apart.
big-
You see that?
Yeah. Is me and Miss Deegan watched this.
So here's what I want to tell you. If you measure how fast these stars are going around the central spot,
Mm.
then you know how much mass is in the central spot. That's how they measured the mass of the black hole. They watched the stars moving around the black hole.
We just went past 2020.
Yeah.
Yeah.
That's a prediction of what's going to happen.
Yeah.
So I hope you guys heard what I said, and I hope it makes sense to you. I hope I explained it so it makes sense. By measuring the speeds
Measuring the speed
of these stars,
of these stars.
you can tell the mass of the black hole.
Oh.
Okay?
So.
So you see the stars moving, and then you
Mhm.
see time in the lower left.
I
So if
see
you-
the time.
So if you take distance divided by time, you get velocity or speed, right? When you're in your car and you cover a lot of distance in a short amount of time, your speed is high, right?
Yeah.
Yeah,
I don't see.
Affirmative.
right. So in this case, if the stars move real fast in a short period of time, then there must be a huge amount of mass in the black hole. By the way, this bright little fuzzball in the center, that's supposed to mark the location of this supermassive black hole.
So, first of all, let me tell you. So, let's say they're moving a distance of, let's say, 170,000 miles per hour in 1 month.
Mm.
That will give us super mass, right?
So if that's a high speed, then that must mean that there's a big mass attracting the thing that's going the high speed. That's
Yes.
exactly how you do it. Okay?
Yes.
Right. So let's move on. And what I'm showing you here is what people measured. And here are the people who measured it. And I worked with these people for years. And I contributed to this project, and they worked on my projects too. Now you see this thing, Nobel Prize. You ever hear of that? Who heard of that?
Me.
Okay. So do you guys know what a Nobel Prize is? Who knows?
Me. I know.
Kenny?
Yeah.
Go ahead. Tell me what a Nobel Prize is.
It's well. No.
Well, let me tell you what I think it is.
Mm.
And then you tell me if you agree. So the Nobel Prize is given out every year to someone who did something extraordinary in science. They discovered something. Okay?
I agree with you. That
Thank
is
you.
affirmative.
Thank you. And here's a picture. Look at that on the right. That's a cartoon of 3 people, and they won the Nobel Prize in Physics about 3 weeks ago.
Wait.
And
now?
they won it because they did work on black holes. And look at these 2 people over here on the right, Reinhard Genzel and Andrea Ghez. They won the Nobel Prize for the discovery of the supermassive compact object at the center of our galaxy. And compact object means black hole. So they did the work over 30 years
Over 30 years.
to get that data in that cartoon animation. Remember the cartoon animation with the stars zipping around? They're the ones who made those measurements. And one of the instruments that they used to do it, I built for the biggest telescope in the world. And they used that instrument. I also used the instrument to measure the mass of the black hole. And that's why they won the Nobel Prize. Now, I told you I'd show you a picture of a black hole, a real picture. This is a real picture. Now,
Wait.
remember
What?
I said that, and you guys told me this, I think, that the only way to see a black hole is to see an absence of light behind it.
Oh.
So in this picture, you see that there's a bunch of light, and then in the middle, there's no light. And the reason there's no light is because the light that was coming toward us got sucked up by the black hole. the
It
black
can
hole.
be very dangerous and it can be very massive.
Yeah, and this one's even more massive. I think this one is 40 million times the mass of the sun. This is at the center of a giant elliptical galaxy called M87. This is not the black hole at our galactic center. This is a black hole in another galactic center. And it turns out,
Another galaxy.
yeah, and it turns out that there's a supermassive black hole at the centers of most galaxies. So, our galaxy has 400 billion stars,
400 billion.
Oh,
and we know that there are 400 billion galaxies, each having 400 billion stars in the universe. And each galaxy has a supermassive black hole at the center. And this is the first picture that anyone's taken of a black hole. And all it is the absence of light.
Oh my
So
gosh.
that's it. Thank you for your attention and your enthusiasm for black holes. And I hope you never get trapped by one, but maybe you can look at it from a safe distance.
Oh, I won't.
And I can take any questions if you'd like.
no,
Sure.
that's it.
Did I answer everything you'd want to know about black holes? So I see some questions here. So how about if I just maybe take the one in the upper left? Upton, is that okay? How big was the black hole that you helped measure? So that one is 4 million times the mass of the sun. And if you put it in our solar system, it's a lot of mass, but it's shrunk down, right? If you put it in our solar system, it would be where the sun is. It would stretch out to roughly where the Earth is. So if you put it in our solar system where the sun is, I think we'd get sucked in. We'd be gone forever. We'd have to go to Mars, maybe. How far is the farthest black hole from Earth? Well, it turns out that there are probably black holes in the centers of each galaxy. So the farthest black hole is the black hole from is at a distance equal to the distance of the farthest away galaxy, which is about 13 billion light years.